So this is an introductory session or the first session on algorithmic thinking in Python. Do you know what is an algorithm? Can anybody tell me what do you understand by algorithm? Why is algorithm so important? What are the things that people expect from you when you are going to get hired in a company? What are the things that an interviewer is looking at you when he wants to hire you? And what is that that is going to relate itself with algorithm? Algorithm means algorithm is nothing but a means to solve a problem. The steps that you need to take in such a way that you are going to solve a problem. So first thing is that there exists a problem. Second thing is that you are going to write something or you are going to find out the steps with which you are going to solve a problem. Right? So algorithmic thinking means you are making out logical decisions. Logical decisions means you are making out methods to think in such a way that you can solve existing problems in the world. So many computing problems are there, so many scientific problems are there, so many advanced problems are there, so many engineering problems are there. All these problems require solutions. In algorithmic thinking with Python, in this subject, what we are going to deal with is that we are going to deal with things or problems and how we are going to solve these problems. What are the major problems that exist? How we need to solve each problem. What is the logic behind solving a problem? Right? You need a logic. You need a logic to solve any problem. Right? Yes or no? So how you are going to devise these logics? Once you start thinking in such a manner, there are famous books like Think Like a Scientist, Think Like a Computer Software Engineer, and so and so and so. Here, as far as we are concerned, we are going to solve engineering problems using Python. We have a lot of applications in electronics and communication engineering or maybe electrical engineering, wherein we are going to solve our problems using advanced computing technology. Previously, before this algorithmic thinking in Python was introduced in your syllabus, this was introduced only from this year onwards. Okay, your seniors did not study the subject. They had another subject called as scientific computing, and not in the first year, in the second year only. Scientific computing deals with the way in which the problems or the scientific or engineering problems are solved in using computers. Okay, using programming languages. That is all about software, right? All engineering problems we apply. For example, in communication engineering, that is what I am going to deal with for you. Even in the future sessions, I am basically specialized in communications engineering. You're going to deal with 5G, 6G communications. Can anybody tell me what is 5G or what do you understand by 5G or what do you understand by 6G? Or what do you think is 5G, fifth generation, right? 4G. I believe all of you are using computers, right? Or mobile phones. There could be nobody in this world today who does not use a mobile phone, right? Yes or no? Is there anybody here sitting in front of me who is not using a mobile phone? No. So what type of mobile phone are you using? What is the wireless network that you are using, 4G or 5G? Answers please, bit louder. How many of you are using 5G? Are you sure you are using 5G? No. How many of you think you are using 4G? Right. What is 5G and what is 6G or 4G technologies? What is that? That is bringing about changes. We'll be seeing all these things. In 6G, we are using advanced artificial intelligence technologies to make our wireless networks more efficient. We need more bandwidth. All these things we'll be seeing as we go ahead. And we have, for the time being, or to begin with, we all need to understand that we need a lot of programming for our engineering solutions. Why I wanted to ask you all these things, why I wanted to tell you all these things is because I wanted to make you feel that there are a lot of things that computers or scientific computing or algorithms can do in solving engineering problems. And you are indeed, it is an essential, most essential ingredient of your engineering course. You will not be able to work in major companies, or you will not be able to devise major equipments, or you will not be able to solve engineering solutions without using one or the other kind of programming languages. And which is the most popular programming language today? What are the programming languages that you know? C, C++, Java, JavaScript, then HTML. Okay, then how many of you have already studied some C programming? C++? Anybody here who already has some introduction to Python? One, two, three. Okay. How many of you know something about C programming? What is C programming and how C++ was developed from C? What is object-oriented programming language? Anybody knows here? There is a huge or a big concept called as object-oriented programming language. Can you tell me, can anybody in this class tell me what is object-oriented programming language? No. So there are a few people who know C, but nobody, no, there is nobody who knows C here, right? Yes or no? Is there anybody who knows C? Please raise your hands. Nobody. C++? Python? Anybody who knows Java? No. Okay. So do you know what is a programming language and why do you need a programming language? What is a programming language? What is meant by a language? Any language. I'm speaking in English. What is meant by a language? Communication medium. Something with which I'm going to speak to you and you can understand that. Am I right? Okay. So Malayalam, I have some certain syntax, certain formalities, certain things I have to speak in this way so that you are able to understand these things in this manner. Am I right? Yes or no? So what could be a programming language? What could be a programming language? You know that what is a language, you know what is language, English, Malayalam, Tamil, so many other languages, Hindi and so on. When I say it is a programming language, one thing is that you have a programming one part here, the other part is the language, right? So there is a language. Language means something that you are going to use to communicate. Am I right? Yes or no? I'm going to communicate something. That's why I'm going to use language. Language is something with which you are going to speak to something else, and that something else is going to understand what you're going to speak. Okay? So programming language is a very simple concept. You are going to speak to your machines. You are going to speak to computers in such a way that these computers are capable of understanding whatever you are speaking and do the necessary things. I am asking, I'm giving you an instructions to write, giving you an instruction to write some notes. When I give you an instruction, what you're doing, you're opening the book and you start writing whatever I say for you to write. Am I right? So it is an instruction that I'm giving and you are doing it. Similarly, in a programming language, what we are going to do is that we are going to give these computers some instructions, or we are going to talk to these computers, talk to these machines, ask them to do something, and they are going to do that things and return us with some kind of results. Or in a more technical style and more fashion words, we can use it, we can call it as an output. You are speaking something to a computer and this computer is giving you doing something and is going to give you an output. This is a programming language. All these things, whatever we have discussed just a few minutes back about C, C++, Java, Python, all these things are nothing but programming languages. Like we have English, Hindi, Malayalam, Tamil, so many other things. We have different languages like C, C++, Java, Python, and so on, so that you can communicate with your computers. Unlike communication between human beings, where we have all these networks and all these things, unlike communication between human beings, communication between computers and human beings, or communication between for the computers, is nothing but you are giving something and you are asking some output. That's all. The thing what you are going to give inside is called as input, and what you are going to get out is the output. In between, what is happening is it is doing some kind of processing, right? Some processing it is being done inside, and this processing requires a set of instructions, and these instructions are what you are going to give using a programming language. Now, I believe that all of you sitting here have understood what programming language is. Is there anybody who did not understand what is a programming language or how you are going to execute these programs using a programming language? So we have seen what is a programming language and what is meant by. We have not seen what is Python, I believe. We have seen what is algorithm. I think all of you understood what is algorithm, right? Algorithm is a series of instructions what you are going to give to this particular programming language so that these programming languages execute these instructions, right? Algorithm here is a set of instructions that you are going to give as an input to this particular program or programming language, this algorithm will be rewritten in such a way that this particular, your computer is capable of understanding what is being or what it has to do. Only if you give instructions to these computers, it can work according to your instructions, right? You wanted to find the area of a circle. What you will do first? Suppose you want to find the area of a circle. What you will have to do? What are the steps that you will be doing? Forget about using the computers. Let us think about doing it manually. You will be given a problem, right? You will be given a problem. Find the area of something like this and whose radius is, say, let us call it as 5 meters, for example. Right? So this is a problem that is being given to you. You are asked to find out the area of a circle whose radius is 5 meters. So what you are supposed to do, first of all, you need to find out, you will write down first radius is equal to 5 meters, right? Second step, step 2, what you will do, area is equal to pi r square. Third, in this what will be area? Area will be equal to pi into 5 square, right? So you have 5 here in meters. So the area will be in meter square, 5 pi meter square. And the output is 5 pi meter square. Sorry, 25 pi meter square. Okay, 5 square is 25, 25 into pi meter square is the area. So it is what we have done. We have a problem. We have broken down into steps. We have written down the logic. This logic is the most important part here. You need to know that area is nothing but pi r square. Okay, and you solve this. Now what we are supposed to do, if you want to find out the area using a programming language, we have to give this formula as an input, right? And then what else we have to do? We have to give the value of the radius 5 also as an input so that you will get the value of the area in terms of meter square. So determining the logic for solving a problem is the algorithm for a problem. So today we have infinite number of algorithms, and writing algorithms is a very important and a difficult task to be solved in the present day world. I'll be discussing with you all the major problems and what are the different very interesting algorithms that are still very prominent today. We'll be discussing a few points related to AI based algorithms. We'll be discussing a few points how we are going to solve our engineering uh, problems using this kind of algorithms, right? So this algorithm should be written in a particular fashion so that your computer or your system is able to understand. The language with which a computer is able to understand is called as a high level language. This is nothing but a binary language which consists of only zeros and ones. Okay, so that is called as a machine language or a high level language. Python is one such high level language. We have two types of translators. One is called as an interpreter and another is one is compiler. Have you heard of what is interpreter? Interpreter or compiler. Whenever you see some politicians speaking in the dais, you have somebody standing nearby, right? Suppose our Prime Minister is coming here, he'll have somebody, he'll speak in Hindi and he'll ask somebody to translate it into Malayalam. Am I right? Yes or no? The same thing that is happening in a computer is called as an interpreter or a compiler. We have two types of people who do these jobs. First thing is called as an interpreter and the second person is called as a compiler. Either one is enough. We don't want two people to translate. Either one is enough. When our Prime Minister speaks the entire speech and then the translator translates it into the local language, it is called as a compiler. That means compiler will be executing all the steps and then only giving it as an input to the system. Interpreter is going to do line by line. That means interpreter executes the program after each and every statement. Now you understood the difference between compiler and interpreter. Compiler is someone who is going to read the entire program, convert it into a machine language and ask the machine to give the output. Interpreter uses line by line methodology. First, one line is being read, it is being executed, solved, and the output is given for that line, and then the next line is executed. So, the major difference between a compiler and an interpreter is that compiler executes the entire program and interpreter interprets each and every line one by one. Okay. So, first thing I am going to tell you about Python is that Python is an interpreted language. Python is an interpreted language. That means that every line you execute in Python will be interpreted by the interpreter and the output will be given to you. Okay. One of the important features of Python programming language. Another important thing is that Python is object-oriented programming language. That means that everything in Python is an object. And in the coming classes, maybe at present, when I delve into object-oriented programming, most of you will find the subject very difficult. The subject is not that difficult. It is very easy, interesting, and most interesting subject that you are going to study throughout your syllabus. So what is object-oriented programming and what are the different features of object-oriented programming? We'll be studying in the coming sessions. Similarly, every feature of Python, one by one, we'll be studying one after the other as we go on. Okay, so today, one feature that we have learned about Python is that Python is an interpreted language. That means that you can solve Python problems one step after the other, one by one, as you like it. Okay, is that fine? So the next thing what we are going to see today is the syllabus. Do you know how your syllabus is being divided? Your syllabus is divided into different modules. Okay. Do you know that already? How many of you have seen your syllabus? No. So this is the first part of our syllabus in algorithmic thinking with Python. In this, we'll be studying problem solving strategies. What are the different problem solving strategies? Importance of understanding multiple problem solving strategies. Trial and error, heuristics, means and end analysis. backtracking, how we are going to solve using computers, the problem solving process, computer as a model of computation, understanding a problem, formulating a model, developing an algorithm, writing a program, testing the procedure, and evaluating the solution. This is the first part of your first module and seems very interesting, right? Yes or no? So in the first module, the first topic that you are going to deal with in algorithmic thinking with Python is problem solving strategies. What do you think is problem solving, or what is problem solving strategy? Whenever you look through a job description, you know what is a job description? We call it in short as JD. Job description for most of the engineering companies, they just ask for what kind of candidates are they looking for recruitment. That is called as a job description. What type of job you are supposed to do. What are the skills that you need so that you can do this job. All these things are specified in what is known as JD or job description. Recently or for the last few years, most of the companies, while recruiting, they ask whether you have problem solving skills or not. So what do you mean by problem solving? What is strategy? And how we are going to define a problem solving strategy? What is meant by problem solving? Can anybody tell me? So let us now understand what is problem solving and what are its different strategies and how we are going to define. As I told you, we have infinite number of engineering problems. We are finding out solutions for different kinds of problems. For example, I'll tell you that, do you know drones? How many of you have seen drones? There are multi-purpose drones, right? Yes, one point. Another one, how many of you have seen an electric vehicle, EV? How many of you have used it? How many of you who know? I own an electric vehicle. So one of the major problems that I face while driving an electric vehicle is that, or while using, sorry, not driving, while using an electric vehicle is that I need to charge the battery. My battery lasts only for around say 400 kilometers is what the company says, but within 250 kilometers I need to keep charging this at a electric charging station or at my home or wherever I want. I want a external source, electric source, to charge my battery so that my battery becomes 100% or battery becomes in such a way that it has sufficient power to travel further distance. This is one of the important problems that we are facing. Similarly, when you design a drone and you want to make it fly in the air, the maximum amount of time with which your drone can fly as of now is only 90 minutes. To design a 90 minutes drone itself, it is too difficult. With a limited payload. Payload is the amount, the weight which a drone can carry. So higher the drone has to fly, longer the time it has to fly, there should be more efficient batteries. So one of the most important engineering problems that we are facing today, maybe there are so many others which I just gave you a example with which you can really understand more easily. That's why I've taken electric vehicles and drones and such kind as examples. These are some of the problems that we are facing, and we need certain strategies to solve these problems. What are the problem solving strategies that we are going to do? So I've defined a problem for you. I've defined a few examples of problems for you. Now researchers are working very seriously on how to solve these problems. The solution to these problems are defined by those strategies. So the answer to the question, problem is a question. The answer to this question is the strategy to solve a problem. Strategy means the method or how you are going to solve the problem. That is all about problem solving strategies. So in the next class when I deal with this, I will talk to you about I'll talk to you about how you are going to write answers for the questions that come in exams with respect to problem solving strategies. Okay. In the coming sessions, I will be giving you in detail about how we approach a problem for solving the main problem. Then next is about importance of understanding multiple problem solving strategies. So we have just started understanding the importance of understanding multi-problem solving strategies. What is multi-problem solving strategies? When you are devising any product or when you are working with any of your engineering solutions, you need to do a lot of research, right? You need to have an understanding, you need to have a background of what are the things that is going to work, how you are going to do, or how you are going to solve the major problems. In most cases, what happens is when you try to solve one problem, another one pops up. എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഒരു പ്രശ്നം സോൾവ് ചെയ്യാൻ നിങ്ങൾ ശ്രമിച്ചുകൊണ്ടിരിക്കുമ്പോൾ വേറൊരു പ്രശ്നം വേറൊരു സ്ഥലത്ത് pops up. So these are all the problems that we might face when we start working on engineering projects, when we start working on product development, when we start solving major problems. So this is what is called as importance of understanding multiple problem solving strategies. Basically, what are the skills that you need to solve a problem? Can you tell me, in general, any engineering problem, what are the basic skills that you need to solve a problem? First of all, you need to understand, you need to have a thorough understanding about the problem that you are facing. There should be a lot of research work. Say, for example, I gave you two examples. Now, one is about the drone technology, and the other one is about what was that? Yes, electric vehicles. So when I say you should know, you should be very strong in your research about the problem. You should be able to understand What are the different methods with which a battery can store energy? How is potential difference stored? What is current? What is potential difference? Okay. How can a battery store? What does battery store? How does a rechargeable battery work? The next class, when you come, you can make a small note about this and bring it to me. I'll just check it out and let you know. Okay. So first thing what you need to do is that you need to have a research. You need to do some research on how you are going to solve the problem or what is the existing problem. You need to have a thorough understanding about the problem as such. Okay. Another next thing what we need to do is that you need to have different options, different methods with which you can solve the problem. So, for any research work or for any kind of product development or any kind of engineering issues, we need to define a problem statement. Just now we have discussed about writing a research journal and all, right? So one of the most important steps or the first step is defining the problem statement. You are defining a problem. The next topic what we are told is about how we are going to solve it. That is problem solving strategy and how we are going to define it. There can be multiple methods. We look into all the options. For a generic problem means, do you know what is meant by generic problem? Generic problem. What is meant by gene? What do you understand by the word generic? It is very easy. If you cannot understand its meaning, you can just rethink about what it is. Do you know what is etymology? Anybody here? What do you understand by etymology? The study of origin of words. What do you call it? Study of origin of words. What is that? What do you call that? Etymology. General, generic. Generic means a problem that is faced by a group or in general. A problem that is faced by the problem of power or battery power is generic. Generic means the entire team or entire set in general that problem is existing for all. Right? So that are called as generic problems. So we'll be studying what is trial and error method. We'll be studying what is heuristics, end and means analysis. End justifies the means. You might have heard of that. Very common Machiavellian topic. Do you know who is Niccolo Machiavelli? ലക്ഷ്യം മാർഗത്തെ കേട്ടിട്ടുണ്ടോ? What does it mean by end justifies the means? Do you know who is Machiavelli? How many of you know him? Heard of him? Please raise your hands. Good. So can you tell me more about Machiavelli or Machiavellian concepts? There's a big concept. This Machiavelli was an Italian politician or political thinker. I would rather like to call him as a political thinker. He was one among those who said end justifies the means. That means that whatever you do, the outcome is more important than how you do it. Right? That means that if you win, you can do anything. Or if the end is right, you can do anything to achieve that end. That is a very famous, world famous quote which always says that end justifies the means. The contrary to that, there are so many other theories. Machiavellian theory was in the 14th or 15th century. Our own greatest political thinker, Mahatma Gandhi, reversed these concepts. He says that means is as important as end. If you do wrong deeds and end up in a successful result or in a positive result, it doesn't mean that it is good. So there are controversial theories on this. There are a lot of things that thinkers have given. End justifies the means is one of the most important theory that Machiavelli has once upon a time developed. We'll be seeing that what is means and analysis in the coming lessons. Backtracking and what are the different problem solving strategies and why do you want to bring all these things into your syllabus? Maybe some of you might have been asking in your mind that what is all these things and why do I want to study all these things? All these things have certain impact or significance in your course. We'll see that, and as we go on, you will understand its importance in the coming lessons. Okay, so what is this? How are you going to solve the problem? Problem solving analysis. Next one. Computer as a model of computation. Understanding the problem. Formulating a model. Developing an algorithm. Writing a program. Testing the procedure and evaluating the solution. This is the next part of the first half of the first module. First module is divided into two halves. In that, the first half is what is shown in the screen. The second half I'll be showing you just immediately after this. And the second half will be studying the computer as a model for computation. What are the scientific problems that we cannot solve manually, but we need computers for that? So how do you understand a problem? How do you find out a solution for that problem? What is that model that you are going to build? That you need to keep building. Multiple models you need to keep building throughout your course, throughout your different strategies. Okay. Then we'll be jumping into the first step of how we are going to develop an algorithm. Right? After that, we'll write some small basic programs. This will happen in this week. Then we'll be testing the procedure for solving these problems or writing this program and getting the answers. Now we'll see that we have a problem, we have written an algorithm, we have written a program, we have executed it. Now we'll see that whether this is a proper solution or not. We'll test the program that is called as evaluating the solution for the problem. Is that clear with all of you? Essentials of Python programming is the second part of your first module. We'll see creating and using variables. What are variables in Python? What are numeric and string data types in Python? Using the math module, what are modules, what are packages, and how you will be importing these packages and creating solutions to the problems is what we'll be seeing, how we are going to use the math module. And we'll be using standard Python libraries for handling the basic input output operations. We'll be learning how to get the values from the console. What are the methods through which we can get the output, and we'll see the basic operators in Python. With that, we'll be studying the entire first module. We'll be completing the first module. So in this particular session, what I've been talking to you so far is all about introduction to algorithmic thinking in Python. In a small recap of what we have done so far, we have understood the problems, problem solving strategies, basic ways in which or methods through which we can solve multiple problems, and how we are going to use computer as a model for problem solving, right? We'll be learning how to write an algorithm, writing a small program, getting introduced to computers, start communicating with computers, and start understanding what is that, what is the subject. The more you learn about the subject, you will fall in love with the subject, and more you start falling in love with the subject, you can achieve a lot of interesting things. There are so many very interesting projects done by our students. You can have a look at that. Many of them are so interesting. But for all these things, you need to understand the basics of Python. So Python will be the skeleton of your entire course. Okay, the coming semesters also, if you want to study communication engineering, if you want to study what is happening in 6G, if you want to study what is artificial intelligence, what is deep learning, what are the different mathematical models, for all these things, you need to know the basics of Python. And Python is the most popular language used today for all kinds of communication, for all kinds of scientific computing. Not only scientific computing, even much beyond that. Python is the basics of data science. Python is the basics of machine learning. Beyond all those things, we are going to use all these concepts. You cannot say that machine learning, deep learning, and other things are a part of a different branch of engineering. It's not like that. Everywhere, for communication engineering, for 6G technologies, for everything, we require Python programming language as a foundation. So it is essential for you to learn thoroughly and develop the programming skills in the first year itself, in this particular semester when I'm teaching you itself, so that you gain sufficient knowledge in programming. So thank you all. Thank you very much for listening to me. Okay. And we'll see in the next class. Thank you all.